Okay, so on these first 6 problems, we just have to know what they're asking us to do. For instance, on 1, it says f plus g of x. So we're just adding these together. You actually don't even necessarily have to write it out if you just want to look at what your like terms are and add them together. Negative 2x squared plus negative 3x squared is negative 5x squared. And then 2x and negative 3x add together to get a negative 1x. And then negative 1 and negative 1 add together to get negative 2. That's all my like terms. That's all I have to do, so that's my answer. And as long as we're adding, it's really as simple as that. If we're dividing like on number 2, we're just sticking f on top of g in a fraction. And I want you to assume that that does not simplify, because the chances of it simplifying are like 1%. And so you'd be better off just assuming that it doesn't simplify, because there's nothing in common with all 4 of these terms that I can cancel out. So that's my answer. When I multiply, this is a little dot that means multiplication, not the open dot that means to plug in. So I'm multiplying f times g, but this 2 means I also want to plug into where x is. So there actually is an easier way to do this. If you FOIL first and then plug into, that's fine. But if we do them like at the same time, if I write 2 squared minus 7 and then 2 plus 5, and then I go ahead and work out those parentheses and then multiply, that's actually quicker and a little easier than if I had left it as x squared minus 7 and x plus 5 and FOILed and then plugged in 2. But either way is fine. They're both correct ways of doing it. 4 minus 7 is negative 3. 2 plus 5 is 7. So we multiply those together and get negative 21 for our answer. Then 4 is probably the hardest one that's on here, because we have to subtract, but we also have to plug in t minus 7. So there's not really an easy direction to go with this. They're pretty much the same either way. We need to do t minus 7 squared minus 7. That's this part with the t minus 7 plugged in. Then I'm going to subtract this part with the t minus 7 plugged in. So that means I've got this t minus 7 minus 2, but all of that is being subtracted. And so I have to be careful to make sure that I actually subtract all of this. So we need to do 2 things. We need to FOIL t minus 7 squared. Notice that t minus 7 squared means t minus 7 times t minus 7, which requires you to FOIL. This is not just t squared plus 49, it's t squared plus 7t, minus 7t, not plus 7t. T squared minus 7t minus another 7t plus 49. That is just this part right here. So then we would still have the minus 7. We still have minus, and then we can drop these parentheses. T minus 7 minus 2 does not mean to distribute the negative 2. It's saying I have a t, a negative 7, and I'm trying to subtract 2, which means that I'm going to combine negative 7 and negative 2 into t minus 9. And that's still going to be in parentheses because I have not yet distributed that negative. So I have the negative to distribute. I also have some like terms I can add together. So this part will be minus t and plus 9. So I have a t squared. I have negative 7t, and negative t, which give me negative 15t. And then I have 49, negative 7, and positive 9, which gives me 51. Yeah. Thanks. So that definitely is because of plugging in t minus 7 as well as subtracting. That's a little bit more tricky. So that's probably about as hard as that kind of problem can get. It shouldn't get any harder than that, but there will probably be like a low, medium, high kind of situation. One that's super easy, one that's kind of medium, and there could be one like this that's a little more complicated that you have to pay more attention to. All right, when we have the open circle like this, we plug in, but we always plug in backwards. So I'm going to take f and plug into g. So I'm going to take x plus 4 and plug it into g. So I'm doing x plus 4 squared, which means I have to FOIL. And that's going to be an important thing to remember. It shouldn't come up a huge number of times on the test, but even doing this once incorrectly would be bad, obviously. It's a silly mistake to make. If I FOIL this out, I get x squared plus 8x plus 16. On 6, they didn't use the open circle, but this is the same idea as if they said f open circle g. We're plugging in backwards, and so that means first I need to take x squared and plug it into g. So if I just take x squared and plug it in, that's x squared plus 2. And then it's asking me, now that I know what g of x squared is, take that and plug it in to f. So that means I'm going to have negative 3 times x squared plus 2 minus 5. And then I'm going to work out what that is by distributing and adding like terms. So I get negative 3x squared minus 11. Now, when it asks us to verify algebraically that two things are inverses of each other, what it wants us to do is f of g of x and also g of f of x. And this was where, if we did it right, these were supposed to cancel out and we are supposed to get x. Okay, and so you're going to have to remember, based on these instructions, that that's what you're supposed to do. I plug them into each other, and then I'm trying to cancel out until I get x. Also, remember, this is where you need to show work, because the work is our answer, not the fact that we get x. So if I do f of g of x, I'm going to take x cubed plus 10 over 3 and put it right here where this x is. That in itself is can be kind of a weird thing to have to plug in. And then order of operations are going to matter. I can't cancel the cubed root and the x cubed until those are the only things that's left. Okay, so that's going to be like my last step. Before that, I'm going to have 3 over 1 times something over 3. Those 3's can cancel. Every time you cancel something, write out what you have left. That way you know that you're showing enough work. So I canceled something, I'm going to write what I have left. Now I can cancel something again, because 10 minus 10 is 0. And then I'm going to write what I have. Cube root of x cubed. Now, because it's just x cubed underneath there, those things cancel and they leave me with just x. But you writing it out here initially, marking out a whole bunch of stuff, and then writing this last step, like these 2 steps aren't enough. You need the steps in between that. And then we're going to plug it in the other direction. So I'm going to put the cube root of 3x minus 10 into this x. Now this time, and what should happen is they should do the exact opposite. So this time the cube root and the cube do cancel out at the beginning, because this whole thing is being cubed and all of it's under the cube root. So that means I just have 3x minus 10 plus 10 over 3. Right here, those 3's don't cancel. The 10's do, but if you try to cancel the 3's right now, you're wrong. That's bad math. These cancel, and you get 3x over 3. Then the 3's cancel, and you get x. Okay? But remember, it's the work you're showing, not just the fact that we got x. If you don't get x at the end, I mean, you did it wrong, but it's the work you're showing to get there that we want to have. So now we kind of transition to a different section. This was 1.4, and so it may be helpful right before the test for you to look at the 1.4 notes and look at those different translation rules. I can plug in A, B, C, D, and E to my calculator and see which one matches this. That's a lot of time, and if I don't have any other ideas of what to do, that's what I'm going to do. But this is an absolute value function. It has to be based on my answer choices. So it might be better for me to graph just y equals the absolute value of x so that I know that it starts like this at 0, 0, because then I can say, well, this moved left and down. And because of the numbers in here, it must have moved left 1 and down 1. And what we can do is we can say left 1 is inside, and it's the opposite of what I think it should be. So that means I should have x plus 1 inside my absolute value bar. So that takes out A, B, and D. And then down 1 is outside, and it is what we think it is. It's minus 1. So that's C. And then obviously it's a good idea if you come up with C to then graph it and check to see that you're right. Inverse functions, so that's where we switch the x and the y. Now there's not a y right now, but f of x is really the same thing as y. Now I can switch x and y and then solve. So to do that I have to add 1, and I get x plus 1 equals 4y, and then divide by 4. And this was where we wrote f to the negative 1 of x, because that's our notation to show that we just found the inverse. And you can either write x plus 1 over 4, or you can write x over 4 plus 1 over 4. Those are the same answer. They're equally correct, like whatever you want to do. If you don't want to split it up, that's fine. If you do, that's fine.
What did you find generally on the test?
I honestly don't know. If it was multiple choice, I'm not sure what the test would have between those two, just off the top of my head. Because it kind of depends on like what test software you use. So this one, we're going to say, okay, that's where y is, switch the x and the y, and then solve. So I need to subtract the 4 over, and it's kind of weird that this is to the 7th power, but how do I get rid of a 7th power? The same way I get rid of a squared, just instead of a square root, I need a 7th root. So that means this is going to be the 7th root of x minus 4, because I'm going to take the 7th root on both sides. So f of negative 1 of x equals the 7th root of x minus 4. And that 7 being there, that's kind of a big deal. It's not the square root of x minus 4, it's the 7th root of x minus 4. Now 11 is a little bit tricky just because of these two concepts are easy to run together. Our graph is a function if it passes the vertical line test. Our graph is 1-to-1 if it passes the horizontal line test. This only passes one of those two tests. It passes the vertical line test because it only goes through the graph once on a vertical line, but it fails the horizontal line test because it goes through twice. So our answer is that this is a function, but is not 1-to-1. Or something to that effect. If you said it was both, then you'd be wrong. If you said it was neither, you'd be wrong. Or if you only talk about one of those two things and forget to even mention the other, then that's partially wrong. So now we're doing some translation things. I think most of us have a handle on the +3 and the -3. The +3 inside, it's part of the super secret opposite society, so it moves us left 3. The outside, this -3, moves us down 3. The 2 in front is a vertical stretch by a factor of 2. So we're going to write those things. The graph is shifted left 3, down 3, and is vertically stretched by 2. Now, I did not graph that to figure that out. I just looked at the equation. You're welcome to graph that. What you would have to do is graph just x cubed to be able to compare it. And from that, you should pretty easily get the left 3 and down 3. But the vertically stretching by 2, it's best for you to remember that rule. A 2 on the outside being multiplied means it vertically stretched. The same thing actually ends up happening here. We vertically stretch by a factor of 4. We have to know that means I'm going to have a 4 outside of my function. This is an absolute value function, so there's a 4 right in front of my absolute value bars. Then I shift 4 units to the right, which is x minus 4. And then shifted 7 units up, which is plus 7. So this is y equals 4 times the absolute value of x minus 4 plus 7. By all means, graph that after you write it and check to see if what you were supposed to do actually happened. These next two have to do with writing equations of lines, basically. On 14, they want to know, are the lines between these 2 points parallel, perpendicular, or neither? Well, let's think about what those 3 things mean. If my lines are parallel, I can actually say something about their slopes. Their slopes have to be the same, okay? Because whatever I go up and over on this one had to be up and over here. So parallel slopes are the same. In a similar way, perpendicular slopes, what I went up and over for one, I had to do the opposite for the other. So perpendicular slopes will be opposite of each other. What that means technically in math is that there'll be different signs and reciprocals of each other. So all we need to do here is find these slopes, which are slope formula, which you need to be able to remember for the test, if you want to be able to get the slope right, is y2 minus y1 over x2 minus x1. So like on this first one, that's negative 8 minus 7 over negative 4 minus 5, which is negative 15 over negative 9, which you can simplify, or technically, because we just want to compare these, we could leave it like that. That simplifies to be thank you, 5 over 3, positive 5 over 3. And then this one is negative 4 minus 5 over 11 minus a negative 4. So that's negative 9 over positive 15. So see how we got the opposite here? Negative 15 over negative 9, and now negative 9 over 15. They're opposites and reciprocals of each other. This simplifies to be negative 3/5. I don't have to find the y-intercepts. If I found the whole equations and graphed them to check, that's fine. You're just doing more work than you have to. Neither would be that I got like completely different numbers. Like if I get 5/3 and then a half, well, those don't have any sort of relationship. So that'd be neither. Give a 1-sentence explanation. The lines are perpendicular. I know we all like writing sentences in math, so it's our like favorite thing. The lines are perpendicular because their slopes are opposites. Something to that effect. Slope-intercept form is y equals mx plus b. And so we can plug in the negative 2 for the slope. We can plug in 3 and 4 for x and y and solve for b. The other way of doing it is to use point slope. And these are really about equal as far as how difficult they are to work out. So it just depends on if you have this equation for point slope memorized. If I do, I just plug in y minus 4 equals negative 2 times x minus 3. And then I distribute and add the 4 over. And it does the same thing as if I had plugged in y, m, and x, and then solved for b. So totally up to you which way you want to do that. I would like to comment that this is one of those times where, like, I know that some of us can do things in our head, and that's great. But if you just write this answer, negative 2x plus 10, and you don't have anything written down on the problem, I'm honestly going to assume that you probably looked at the person's paper next to you. So please write something down. Like, I get that we can do stuff in our head, but that's kind of a lot to do in your head and not have anything at all written down. Don't ever write stuff down and erase it either. That's not helpful. I mean, if it's wrong, you can erase it, but like, don't write it down and erase it just because you think it makes you look dumb because you wrote something down. It doesn't make you look dumb. It's good to write things down. So, anyway, that was a small tangent. Okay, this last page, except for the last problem, is where we're going to graph things. So, even, odd, or neither, we have to remember even is y-axis symmetry, odd is origin symmetry. Neither means that there's either no symmetry or it's just symmetry we don't care about. So pull up your calculator, go to y equals. We should all be able to type this in on our calculator, but this is what my graph will look like. So a square root function does this nice little swoop thing up and to the right. Does this have any sort of symmetry? No, so this would be neither. Just to remind you what symmetry we're talking about, if I had x squared, this is y-axis symmetry, so this is even. If I have x cubed, this is odd because it has symmetry around the origin. So that's the kind of symmetry we're looking for. Either this one where the top right is the same as the bottom left if I rotate it, or this where if I fold it on the y-axis, it's the same on either side. When in doubt, you should probably put neither, because there's a lot more things that are neither than even or odd. Maximum and minimums. Notice that 17 and 19 had the same graph, so we'll go ahead and do those like together so that we don't have to ungraph it and then graph it again. I'm going to remind you how to do it on your calculator. I know the calculator up here I'm using looks different and is actually way easier. If you haven't ever tried this website or app, it's called Desmos. And if I want to know the max and min, I just have to click on it, which is pretty much the most cool thing math-wise that I've ever seen in my life. For you, though, remember you have to second trace and then do either max or min, and you have to find a left bound and a right bound and then have it guess. So make sure sometime between now and tomorrow that you can actually do that and get these answers, because if you can't and you discover that tomorrow during the test, it's a little too late to do anything about it. Our maximum is 0, 2, and our minimum is 2, negative 2. It doesn't have to have both, remember. It can just have one or the other. Technically, we could have multiple maximums or multiple minimums. But so you'll just want to pay attention to whatever your graph looks like. Let's go ahead and do 19, increasing, decreasing, and or constant, so that we don't have to change our graph because that's the same graph we just used. So it's increasing from negative infinity until I get to this x value of 0. Because this whole time from the bottom up to here, I read this from left to right. It starts off going up until I get to 0, then it goes down from 0 to 2, and then it goes up again from 2 to infinity. The only time that we ever, when we are personally graphing something, have a constant place is if we have absolute value bars, or if I just plug in a number. So what I mean by that is like this is constant the whole time, y equals 4. But other than that, the only time that I'll actually flatten out and be constant is if I have multiple absolute values in my graph. Like, it's really hard to be constant in math. Go figure. So, increasing in two places, negative infinity to 0, and then from 2 to infinity. Now, remember with this that you can put brackets around 0 and 2 if you prefer. You don't put brackets around infinity and negative infinity ever. And I only use the x values. I only need the 0 and the 2 that's happening for x, not the 2 and the negative 2 that's happening on y. Then we are decreasing, if I can spell that, from 0 to 2. And I just used parentheses the whole time. If you want to use brackets, that is fine too. 18, graph the domain, or we're going to graph it and look at the domain and range. I forgot my negative sign. To get to the absolute value, remember you do math and scroll to the right, and then it's the first option. So domain is our x values. Left to right, is anything stopping my graph, or does it keep going forever to the left and to the right? Keeps going forever. So my domain is negative infinity to positive infinity. My range is usually the part that has the problem, because I stop right here at apparently a y value of 3. Range has to do with y. So when I look at this point, I only care about the y value. Now, I can get negative infinity just fine, or any negative number here, but it stops at positive 3. Now, it does matter how I write this. I write it with the most negative number first. So is 3 more negative, or is negative infinity more negative? Negative infinity for sure is more negative. And 3 gets a bracket because I go all the way up to 3 and I actually have a point with a y value of 3. I would have to have an asymptote of some sort in order for that to be a parentheses. Because that's the only time, for us at least, that we would not actually be equal to, is if I have an asymptote. And finally, the moment we've all been waiting for, number 20. So f of 2 means to plug in 2. But I have two equations here. I'm not going to plug it into both. I need to pick which one of these is relevant. So is 2 less than 2, or is 2 greater than or equal to 2? It's greater than or equal to 2. So I only want to plug this into the second equation to find my answer. 2 squared plus 5 is 4 plus 5, which is 9.